Okay, this is problem 4. Regulations require that product labels on containers of food that are available for sale to the public accurately state the amount of food in those containers. Specifically, if milk containers are labeled to have 128 fluid ounces and the mean number of fluid ounces of milk in it is at least that, the milk is considered to be in compliance with regulations. The filling machines can be set to that labeled amount. Variability in the filling process causes the actual contents of containers to be normally distributed. A random sample of 28 containers of milk was drawn from the milk processing line in a plant, and the amount of milk in each container was recorded. The sample mean, the standard deviation of the sample is, so we have the sample mean and standard deviation. So this is X bar. So we have a N of 28, an X bar of 127.2, and an S of 2.1. The fact that this is an S tells me this is a t-test. Is there sufficient evidence? As soon as I say sufficient evidence, I'm going to run a hypothesis test to conclude that the packaging plant is not in compliance with regulations. Provide justification. They didn't tell me this, but I'm going to use an alpha equal to 0.05 because that's what we'll use every time they don't give it to us. So first off, what's the claim? The null hypothesis is HO mu, and I'm going to put mu m equals 128. The alternative, well, if it has more than 128, people are happy. All right, they're going to be happy if there's more than 128. They're going to be mad if they got ripped off and there's less than 128. So I'm only going to worry about if there's less. All right, so that tells me, here's my claim. They're claiming 128. I'm looking for a less than test. So I need to define this and let MM equal the true population mean and amount of milk. Really of milk in ounces, but the true population mean amount of milk. Okay. Conditions. As always, we claim that they are met. And we need to determine the type of test, and we're going to run a t-test, and it's going to be a hypothesis test. So T equals X bar 1 minus mu over S divided by square root of N. So I need to make a list of things, and I need my mean. I need my X bar. I need an S, and I need an N. Well, we said the N was 28. The S was 2.1. And the X bar was 127.2. And the claim was that it equaled 128. That's what we have right there. So I'm going to go ahead and plug in my values because we want the probability, well, what we're looking for is the probability that T is less than 127.2. This is 127.2 here. So T equals 127.2 minus 128, 2.1 divided by the square root of 28. And we just want the probability that T is less than. All right. So here we go. We're going to go ahead and plug this information in our calculator. We're going to go stat, test, t-test. My mean is 128. My X bar is 127.2. My standard deviation 2.1. And we said it was a less than. So the probability that t is less than negative 2.015 equals 0.0269. So here's my p-value. Here's my alpha. P-value 0.0269. Alpha 0.0500. So this is less than, so we reject the null. So in this case, our p value is 0.0269. We reject the null. There is sufficient. In other words, we have enough. We have plenty of evidence at alpha equal 0.05 to suggest that the true population mean amount of milk is less than 128 ounces. In other words, and simplified, we could say the machine is underfilling. Okay, the next part. What type of error may have been committed? Well, what was our decision? We rejected. We rejected the null. So the only type of error could be, not necessarily is, could be a type 1. So when you reject the null, the only type of error would be a type 1 error. All right. So that concludes that one.